talking about perimeters and areas. I already mentioned a little bit in a previous talk there about perimeter. Let's talk a little more about it. Perimeter is just measuring the distance around a figure. What kind of units? What kind of units can I use for perimeter? Just the basic units, right? Depending on what type of measuring device I want to use. I can have feet, yards, meters, miles. We have a bigger figure, right? Centimeters, if I have a smaller, inches. Just, whatever suits your fancy, okay? Whatever needs, but yeah, it's just basic units. We call them linear units in, I guess, mathematically speaking. In other words, they're not squared or cubed units. They're just regular old units. Now, there are some formulas for them, but really, if you get down to it, it's just adding up the sides. I mean, if you forget the formula for perimeter, no big deal, because all you have to do is add up all the sides. There are a couple of formulas, though, like for a rectangle. Maybe you're familiar there with it. Usually on a rectangle, you call the two distances the side lengths. You call one the length, the other the width. So you've got L and W, length and width. So the perimeter, measuring the distance around there, well, we've got an L plus a W plus another L plus another W, so you've got two L's plus two W's. One way you see that formula. But again, if you forget the formula, just add up all the sides, okay? Then for the square, there'd be a nice little formula for it, wouldn't there? Because on a square, all the sides are the same. Usually they call it S. So what would be the formula? S plus S plus S plus S, which is 4 times S. 4 times S. Yeah, 4 times S. There are others, but if I just have a triangle, on some triangles, 2 sides are the same. On some triangles, all sides are the same. Some triangles, all 3 sides are. But no matter what, if that's A, that's B, that's C, then the perimeter is you just add the sides up, right? Okay. A couple of them may be the same. If you're having isosceles, you can make if it's an equilateral triangle, all the sides are the same, so you have 3S. So, there's formulas for it, but that's the thing on perimeter. You can just add up the sides. Okay. Let's talk about area, though, a little bit, because area formulas are much more important. Area, we're talking about what? Surface covered. One way to put it. What's on the inside is what we're talking about. Instead of the outside, we're talking the inside. And what is what is that covering right there? Okay? Well, for that reason, we're covering something. We can't just use an inch, because an inch just measures how long that is. It doesn't cover anything. An inch just measures how long it is. All right? Well, to cover something, you need, units-wise, you need square units. Here's what I mean. Say that's an inch by inch. If I can figure out how many of those 1 inch by 1 inch, that's obviously exaggerated a bit, that's a little bigger than an inch. But let's say it is 1 inch by 1 inch. How many of those little squares does it take to cover that? That figure right there. How many of those little squares could I fit in that? That's the idea of area, isn't it? So the units are these squared units. Inches squared. And that's going to be our designation. Square inches for square inches, but you know, centimeters squared, feet squared, yards squared. Any of those units, you can square them. That's the units for area. How many of those inch by inch squares cover that, or how many centimeter by centimeter square? So that's the idea of area. How many of those little square units will it take? All right. Like I said, though, area, it's all about the formulas. Hopefully you know some of these. What I like to do, though, is go through kind of the process here of showing you where these formulas come from. Maybe it's helpful to remember them. Start with a rectangle. Got an L and W. Maybe you're familiar with this one. Maybe not. But let me show you. Yeah, on a rectangle, let's just take for instance. Let's take a rectangle that's 3 length, 2 wide. Well, again, we're measuring the inside, so if I grid that off, it's a 2 by 3. Isn't that 1, 2, 3, 4, 5, 6 square units? 6 is 2 times 3. If I've got a 3 by 4, yeah, not exactly square ones, but let me do it better. 1, 2, 3, 4, 1, 2, 3. Okay. So that's 4, 3. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Area is 12. 4 times 3. So you take the length times your width. That gives you the area of a rectangle. The square, well, it's just kind of a specialized rectangle, isn't it? Supposed to be S on all sides there. So if the length is S and the width is S, you've got S times S. Isn't that S squared? S squared. Okay. Really, what I'm going to do here is just kind of get the next one, the next formula I'm going to get. I kind of get the square out of the rectangle, but I'm going to do the next one out of the rectangle too. Let's talk about a parallelogram, area of a parallelogram. On a parallelogram, you need 2 measurements. Parallelogram, you got parallel sides, 2 sets. Well, you need to know the length of one of them. Call it the base. And you don't need, actually, you could get it, but you don't need the other length. What you need is this measurement here, which is the perpendicular, or the length perpendicularly, 90-degree, in other words, length between this side here and then the other side parallel to it. It's called the height. That's what you need for a parallelogram to measure the area. Here's why. Anybody know that one? Well, here it is. Let me draw another one right over here, so I can cut it up, so to speak. All right. Well, your height, you can measure it. I mean, it's the same height here as it is here. Let's say, and I could cut it anywhere, but let's say I take that little height right there, base here, and cut the parallelogram right along that height right there. So I get two pieces. Well, just so happens, if I take this piece and move it right there, fits rather nicely and gives me a rectangle, which its base, height, b times h, isn't it? Yeah. Area of a parallelogram is you take the base times your height, where your height is this distance through the middle, if you will, not the other side length. Okay? That is area of a parallelogram. All right, well, come to find out, if we have that, then we can get the area formula out of that of a triangle. Here's how. On a triangle, also you need a base and a height. Base, call one of the sides base, and then the height is perpendicular to it, distance. Doesn't matter which one you call the base. You know, usually the one on the bottom they call the base, but we can do the same thing for this side. Do that, and then the height across to there. Either one. Well, here's the thing on that. Let me draw a little more pronounced one. The thing on this is, what I'm going to do is I'm going to get a second triangle, exactly the same, and let me twist it around here. Let me make it even more pronounced. Okay, so I'll make a second triangle, same exact shape. And let's flip that around, take this side and match it up to this side, of course. And what you wind up with is this, isn't it? That's the same as that, just that one's just kind of twisted over. Which is, what shape is that? It's a parallelogram, isn't it? Well, the parallelogram is base times height. That's B, that's H. But I'm only interested in this triangle. Well, the parallelogram is two of the triangles, isn't it? So what's the area of one of the triangles? It'd be half of that. The area of a triangle is half base times height, which is probably one you've heard before. But why is it half of base time? Well, it's because, if you think about it, a triangle is half of a parallelogram. And a parallelogram is base times height. So a triangle is half times the base times height.
So the half is in front of the base versus the half times the base times height.
Yeah, it's times. It's all multiplied, yes. Half times base times height. Okay? All right, well,